Good morning, everyone. It's so great to have such an incredible audience from coast to coast to coast. Typically, we're welcoming people from predominantly British Columbia, but we have a lot of people from east of the Rockies, everywhere on the shores of the Outaouais River and the shores of the Great Lakes, and all of us are on unceded ancestral lands. And we got to appreciate and acknowledge that we're on these lands and learn a huge amount from how, for thousands of years, our forests were effectively stewarded, and bring that into the present era because there's lots that we can do better when it comes to stewarding our land so that we have a sustainable resource base for doing important things like having a sustainable housing construction industry in Canada. I am on the shores of also known as Burrard Inlet, on the ancestral lands of the Squamish and the Tsleil-Waututh. It is important as we move forward in today's program to have an understanding of the elephant in the room. It can't be ignored because it really influences what we're doing today on a long-term basis. And it is an acute crisis that we're in. It's the biggest trade and economic debacle that we've confronted, but it's also a long time simmering challenge we have in this country. Right now, the discourse is dominated by trying to find new markets. And one thing we really, really have to appreciate, it's not just about extracting traditional resources and sending them off to far-flung lands. We have access to an unbelievable art market, where there is huge demand for different types of product. And that market is our own. It's our domestic market. And that is an opportunity on the housing front because we need in British Columbia about 600,000 new housing units by 2030. We need about 3.5 million nationally. This is to meet growing demand and a backlog. Under current construction rates, we will not meet these requirements until the 2040s. And that's largely a function of an inadequate labor force in the construction sector and a very, very old construction labor force, where 1 in 4 workers are projected to retire in the next 10 years. So if we continue to do what we're doing under the current with the current approach to construction, our housing crisis is going to get worse. It's not going to get better. And that's where we have a big, big opportunity. Manufacturing homes in plants is the only way that we can make these step changes in productivity and really begin to increase the output of our housing sector. Every one of these homes that you see in front of you was built in a manufacturing plant. The top right was the first passive multifamily construction project in North America, manufactured in a plant in Abbotsford and sent off to a remote part of British Columbia, Bella. All of these homes that you see in front of you were manufactured in Canadian plants. And this is a big opportunity. Manufacturing plants, manufacturing jobs, manufacturing homes. We're really focusing on British Columbia, but right across this country, we have so many innovative, small, entrepreneurial manufacturers, and they struggle. They go ballistic with demand, and then they go through slumps where there's inadequate demand. And one of the most important things that we need to do to drive the growth of this agenda is create stable long-term demand for the offsite manufacturing sector. This is an opportunity, an ace card opportunity, because we can deliver on affordability and housing supply. It's the only way we're going to get to building near zero new construction industry-wide, and it is a big economic opportunity for the country. Um, Inadequate demand is something that we have to tackle. There are so many inadvertent barriers to that increase the cost, increase the time, and increase the risk for offsite construction. Um, they underlie this problem, but this is a unique issue, is the inadequate demand. And this is public sector projects, it's private sector projects, it's social sector projects. We don't have the confidence to procure from the offsite sector. And part of it is procurement challenges. Uh, One of the first things that we have to do is steadily grow demand. And there's some unique opportunities, and we see incrementally the province and the federal government starting to wade into this space. Um, there's no policy commitment as of yet, and local governments are playing a role. This is an extraordinary pre-approved, digital, adaptable design for six-story rental, market rental, non-market rental, and commendably, because of Metro Vancouver's leadership, it'll be pre-zoned in about a dozen municipalities across the Greater Vancouver region, and it'll be available for being used in other parts of the province. You'll see some links that are available for finding out more about how you can download this free design, which you can adapt for unique sites that you're working on in your communities. City of Kelowna is doing spectacular work, and this is a modular offsite-ready sixplex. And I'd strongly encourage you to check out the work of the City of Kelowna when it comes to local governments supporting standardized design. The definitive methodical pathway that they have laid out with clear understanding of ballpark costs for utilities, for roads that are necessary to pay, and all of your permitting fees are laid out there step by step by step. It's something that local governments are able to learn a tremendous amount from. And then these standardized designs are not pre-zoned, but they have the potential to be. And this is a great initiative of the provincial government. These standardized coach and multiplex designs, very imaginative. There's a link there. You can check them out. And then it brings us to the Innovation Building Group. And they have a whole range of Part 9 quadplex designs, as well as multifamily designs, 3, 4, 5, 6 stories. You have an opportunity to adapt those designs to the unique conditions of your community. And this is a spectacular suite of standardized designs. And they're so spectacular because of the deep integration of different facets of traditional building construction with cutting edge technologies. And what Rod Nadeau has been able to do with his decades of experience as a builder is work really effectively with engineers and architects to design buildings that are really simple to build, that can be built at speeds far more rapidly, and are really easy for tradespeople on site, and a pleasure for tradespeople on site to work with. What Rod has is a trades first philosophy. If it's easy for our trades and they're enjoying the work on the site, you're going to have a good project. So you may not agree with everything that Rod has to share, but it really is. I know there's going to be gems that you're going to be able to take from Rod's presentation today. And backing Rod up is Natalie Douglas. Natalie is the program manager of the Zero Emission Building Exchange at the Zero Emission Innovation Center. And ZEBx has done some really impressive analysis doing cost comparisons of near zero new construction. And the cost analysis that they've done has included projects done by Rod Nadeau and one of his companies. And you are going to be very impressed by Natalie's critical analysis that shows that you can build near zero at below the cost of traditional construction by standardizing designs and having a really, really integrated approach. Natalie is a real thought leader in bringing together diverse players and extracting learnings from the best of what's happening by local governments, by builders, by developers, by different players in the construction industry. So I'm going to pass the baton over to Rod, and he is then going to pass the baton to Natalie, and she'll pass it back to Rod. Thank you all. Hope you're going to enjoy this show.
Well, it's nice to be the builder in the room when we're talking about housing and how to build a lot of housing in Canada. And we've been specializing in multifamily housing for the last 20 years, and before that, custom homes. Here's a little presentation outline of what we're going to be talking about today and some key takeaways. But first, I'd like to just introduce myself. IBG has been building high-performance homes since '88. We're a builder-developer, and we self-perform most of the work on our sites with our own crews. So I'd like to give you a little history on what we have tried, what worked, and what we learned from. So Mountain's Edge, we built that in ICF with a handrail floor system, central HRV, some electric baseboard heat, and gas hot water. Then we moved on to Palliser Lodge. It's a 4-story condo hotel at Kicking Horse Mountain Resort. And there we learned that we did not need a massive gas makeup air unit in our parkade. It never got cold enough to come on, thanks to the ICF walls and the foundation. And then our first off-site panelized wall construction was the Aspens in 2008 at Kicking Horse again. And moving on, 2014, we built this Solana building in Whistler, and we switched things up. We went to standard 2x6 open wall framed on site, but we added an 8-inch SIPS panel on the outside to get the extra insulation that we needed. And but we just used individual HRVs, heating and hot water. It worked great, but it was just too complicated and too difficult to scale up. We realized we needed some better building science to properly inform our decisions. We then spent 2 years working with BCIT to energy model our buildings and tried thousands of simulations to find the most cost-effective ways to build high-performance buildings. Then we did a control study on how to run the heating, cooling, and ventilation systems. Then we monitored the buildings for 2 years for air quality, temperature, CO2 levels to determine performance, comfort, and air quality. And then that led us to our Radius building, completed in 2018 as a 45-unit rental apartment. And we now have 7 years of energy monitoring the Radius building, and it's performing between 69 and 72 kilowatts per square meter per year for total energy use. And that number includes everything, the parkade, elevator, EV charging. And here we used a similar double wall like we use in our single family homes, a central Swagon ERV with a Mitsubishi heat pump. Most important lessons learned, a higher performance ERV made the most long-term savings. Thermal bridging has a greater influence than we thought possible on performance, and that cooling is now the dominant load. We're no longer designing our heat pumps and our systems, HVAC systems for heating, because cooling has overtaken that as a load. But the double wall system that worked well in the single family homes and duplexes was time consuming and expensive to make the soundproofing and fire separations work. We used a hybrid heat pump and gas boiler for the hot water. It did not work out that well, and we had to change it over to a sanded heat pump system a few years later. Orion in 2019, with lessons learned from Radius and BCIT, this is the building where it all came together. We improved the central HVAC system and controls based on lessons learned, went back to standard lightweight wood framing and exterior insulation, and lowered our costs while increasing performance. And then we came to Ozone Golden, which we completed in 2023. More lessons learned on the central systems and how to simplify the details and designs. This is the building that inspired us to create the IBG Library of Standardized Designs to share our collective knowledge on how to build high-performance, affordable buildings the easy way. This is our next generation training program. And over to you, Natalie.
Thanks, Rod.
Okay.
So I think Rod just covered a lot of different context about IBG, its history, and where we are in that placement between high performance standardized designs and high performance buildings. He spoke about a lot of these different types of things and why I'm here. So I'm the program manager of the Zero Emissions Building Exchange, a program area of the Zero Emissions Innovation Center. And why I'm here is really to be that validator. So Rod is such a great case study for so much of the work that we're going to be talking about today. And ZEBx as a organization or as a program area is really focused on elevating leaders like Rod. So we were launched back in 2018. So pre-ZEIC even being started, or the Zero Emissions Innovation Center. And from the very beginning, it was centered around industry. We want to elevate leaders. We want to bring a lot of networking, educational opportunities together to try to figure out how to tell other industry professionals what is possible, what is realistic, and what we can work together to achieve. We can move to the next slide there, Rod. So I don't want to say that ZEBx is the experts on all things offsite. We have a lot of folks within our network, local governments, BC Housing, the province, builders who are working on this. And so we are increasingly getting into this space and trying to see where overlap is happening. We have local governments looking at, are there any solutions to increase affordable housing? We have the province working on that catalog for standardized designs. We have BC Housing working on pre-approved Part 3 designs. We have builders adopting offsite components and advocating for fully modular or panelized systems. We have manufacturers in BC developing those components. So we're not the experts, but we do have a lot of experts in our network, and I think it will be helpful to offer some context. We are the platform to be able to elevate those voices. So on the screen here, you see a video that we published last year where we do that. We elevate a couple of different leaders in this space. And in BuildX Vancouver, we also focused a lot of our content on that intersection of standardization and high performance building, low carbon building. Next slide, Rod. So just to take a step back and make sure that we're talking about at a high level, like we're clear on what we're talking about. And that is, what is that connection between offsite construction and high performance resilient low carbon buildings? So on one hand, there is the intersection that we like to talk about, lower operational emissions, and that we can get to tighter building envelopes ideally. There is reduced construction waste and material efficiency when we're talking about prepared, panelized systems. And these are not all inevitabilities, but this is definitely something, if we do well, we can get massive gains in reducing emissions. Additionally, we want to be seeing increasing speeds of construction. We have a strapped labor force, and so these components of that intersection are incredibly important. And when I do say offsite construction, I do mean both the whole building modular type as well as the component base. This might be very clear to some folks, some experts in the room that talk about this all the time. For those who are a little bit more novice, just clarifying that when we're talking about Rod's case, he's talking about some bit of a hybrid form of prefab. We're talking about both the panelized systems, but also some repeatability tactics or prefab tactics where, you're using framing tables on site. So when I speak about this, I'm talking about all these different features of trying to make construction more efficient through repeatable processes. And, at the end of the day, I think Rod's going to talk about this a lot. Bespoke case-by-case buildings are always going to be more expensive. And I think that's going to be hit home when Rod shows a couple more examples. Next slide, Rod. I did just want to highlight that when we're talking about high performance and low carbon homes, oftentimes the very easy target for saying it is the reason why housing is one of the big reasons why housing is more expensive. But as Rod is going to demonstrate to us, this is not the main reason. And a survey that the Zero Emissions Innovation Center did last fall, engaging with folks in our building community, definitely demonstrates that the energy efficiency requirements and emission requirements are not the thing that at the end of the day is contributing to increasing costs. It is part of the picture, but it is not. We shouldn't be addressing these things together, not just deciding to cut out these tactics that will ultimately lead to better homes. Next slide, Rod. Something to note quite importantly is that surveys only go so far in convincing people. Rod and the case studies that we produce here at ZEBx and other really great organizations across the province and the country goes into detail about what exactly are the components that you can use in your buildings that will result in affordable, high quality homes. Next slide. This study that ZEBx produced a couple years back is one of our most compelling. On the far right, you can see that is one of Rod's projects. So coming at a 32% discount rate as compared to a baseline, we looked at 7 step 4 or passive mid-rise multi-residential buildings. And we saw that all electric buildings with air conditioning and passive features can be constructed for less than the average cost of a code minimum building. So the baseline was built by a cost consultancy that we engaged to help us rate this case study. And I kind of want to there's so much to dive into in this case study, but we're strapped for time. So I'm just going to highlight 2 key components that came out of this study. And the first one being contracts. So how did the projects that saw the large cost savings, the 2 projects with the lowest construction costs relative to the baselines were constructed by developer builders, and the type of contract also matters. So in the lowest cost scenarios, they included contracts that allowed the builders to have varying degrees of input in the design before construction began. So involving the builder in the design phase certainly reduced the cost or kept them from escalating through construction. And that was a key component that we heard from all the projects in this study. The next piece, I just spoke about it, is that repeatability feature. So there was a lack of familiarity with some builders on the projects that came above the average. Some of the project teams were just unfamiliar with how to build the building. Rod spoke about this really briefly when he referenced BCIT. If you get really strong on the basics, the core green building principles, or just building a very airtight home, that will serve you well if you can repeat the same design and get good at those basics. And at the end of the day, if you move on to the next one, the next slide, Rod, here, you can look into the mechanical systems and how different mechanical systems were associated with cost. Overall, the building that we're looking at here with Rod's, the building came out at a 32% discount as compared to the average code minimum building with cooling. And Rod has been tracking data after the fact. The apartments heat for between $30 to $50 a year and have performed well in negative 40 degrees Celsius and during the heat wave of 2021 when it was between 41 degrees and 48 degrees Celsius. So these are resilient homes. They came in at a reduced cost as per the norm. It was built. It was certainly a project that kept the builders, those who are building the project, in mind when they were designing the buildings. And I could dive into so many other pieces about cost savings and key considerations of the building systems themselves, but I think it's much better to pass things over to the builder himself. So over to you, Rod, to dive into some cost-saving components.
Okay, I get asked a lot what our secret sauce is and how do we build at a 32% discount and deliver the best performing buildings in BC? Well, you start with a great team and keep working together to continually improve each building. That's the main secret. Every building we do is a little better than the last one. So it's great to work with a highly skilled team and experienced architectural team. So Chris, Jordan, and Daniel C8, they immediately got the value of our standardized designs and their applicability across Canada to lower cost and improve performance in buildings. And then Stuart Hood from Introba, he's been the voice of science and practical engineering to design the systems we need in high performance buildings. And Richard Kadulski has been my mentor for the last 35 years on what works, what does not work in building envelopes and integrated design. He ensures we do not repeat the past mistakes in BC. Ian Cumming from Rove Engineering, make the building easy to engineer. That is the main message. If the design is a complex structure, it will cost a lot more to build. Then we've worked with LMDG for the last 25 years on building code reviews. So have all your code issues worked out before applying for the building permit. Excuse me. The best approval advice I ever got was from Caspar, the building inspector in Golden. Simply give me a fully coordinated set of plans with nothing missing, and I can do my job without having to get all the consultants to correct their plans. And that is just so true. When you apply with a complete set of plans, it just goes so much smoother. So how do we save millions of dollars on each project? Simple. Optimize the design to make every trade's job easy. This includes all the engineers. Simple designs and, most important, simple details that are easy to execute on the job site. Try to have every material and system perform more than one function. Like line the footings with poly. Provides a water barrier and capillary break for the footing. Allows us to use 2x6 for the footings instead of 2x12 or 2x10s. All the wood is reusable as it strips off clean. It's much faster to form, especially over uneven ground. And ICF foundations with compatible waterproofing products. Faster to install. It's great. Lego for carpenters. You no longer need to heat the parkades, even in climate zone 6. The warm parkade means we do not have to insulate all the plumbing lines in the parkade ceiling. The warm parkade can be used for storage now that it is always above freezing. Wood floor system above the concrete parking instead of a concrete podium and transfer slab. We get a 2-hour rating with 3 layers of drywall. Gives us lots of room for mechanical, electrical, and insulation. We get a warm first floor. We can run our mechanical in the floor system. We don't need hangers. It's much simpler and faster to install. This saves us about $1 million per building, especially if you're in a high-cost concrete environment, which is pretty well everywhere outside of the main cities in BC. And wood-framed walls that are the structure for floors above then turn into garages, which are a great profit center, not a cost center. No need for specialized trades for a structural slab. Simple carpentry work for the framers. And it takes about a month off our schedule. And the finished garages can be rented or sold as a value add to the condos. Optimum value framing. I learned this 40 years ago from a carpenter who learned it 40 years before me. Simple, line everything up from the foundation to the roof at 24 inches on center. Trades love it. They can have straight runs for plumbing and ducts. We reduce the number of drops to almost none in the building. saves us about 15% of materials. The ability to run all the plumbing and HVAC in the walls and floors. It's faster to frame, much better vertical load bearing with all vertical loads lined up, and makes it easier to engineer. And there's less waste, especially on plywood, as the buildings are designed in 2-foot increments. And it's easy to plan for prefabrication. On our commercial level, where we have one, we do a wood floor above, no need for a concrete podium suspended slab. It's faster, costs way less than concrete podium, takes a month off our schedule. We have room to run the mechanical, and it can be prefabricated on-site or off-site. Here's our A team in Whistler and Pemberton. Design buildings that optimize the skills they have today. You know, it's simple. The more difficult the design is to build, the more it costs. You know, real world construction site weather conditions. You know, we're in Canada, it snows and rains. And here's some pictures of our on-site prefabrication with our framing tables. So on-site or off-site, prefabrication increases precision, lowers waste, and speeds up construction. Off-site can take months off the schedule. Open wall systems fit into the standard municipal approval and inspection process. Everything can be inspected on-site in the standard construction schedule. This is great. Craned right off the framing table to installation. It's even faster if we crane it right off the delivery truck onto the floor. Makes framing in bad weather so much easier and gets you a better quality job. Also, it's a simple standard 2x6 frame building, which will turn into one of the most climate resilient and energy efficient buildings in Canada. You know, there's numerous offsite framing companies from fully manual to fully robotic factories. Structural Truss offers a full service with lots of capability, walls, floors, and trusses. Aerotech and Revelstoke, smaller, less mechanized manufacturer. Tag Panels and Squamish, they just finished Vienna House in Vancouver with their closed panels. BC Passive House in Pemberton, a Paradigm and Barrier with a fully robotic factory. What do they all have in common? They can easily build our buildings and optimize their production because of the repeatability of the buildings and the wall panels within each building. So here, how to get a free mechanical system. Drop ceiling and bulkheads are a pain in the, and they come as a consequence of your typical mechanical system design. They can easily cost more than the mechanical system. What if you simply design them out of your building? You get 3 weeks to a month out of your schedule, and the cost savings pays for the mechanical system. This is our last bulkhead in 2015. Never again if we can possibly avoid them. Nobody ever said, look at my beautiful bulkhead. So this is a full-scale plan of the HVAC ducts in the rooftop mechanical room and attic space. They all fit in the walls and drop straight into the units. We overlay this on the structural plans and design out all the conflicts. Then we add the plumbing stacks, sprinklers, and water mains. Every trade gets their space with no conflicts. Here's the mechanical room ready to hook up the individual ducts from each unit to the central distribution. The duct runs with a balancing damper that are accessible in the mechanical room. Ducts in round holes. They are so much easier to fire stop. They can be drilled by the fabricator with their CNC machines in the shop or carpenters on site. No chainsaws allowed. For the project managers listening today, now that we have a good BIM model, we do the layout on site for the trades to ensure they put their stuff in the right place. We color code every stud cavity for the mechanical and plumbing. Each trade gets their stud cavity and they're told not to put anything in another trade's location. Make it simple on site and easier to do it right than wrong. Here's the Swagon ERV with preheaters installed in Golden. There's a Mitsubishi 18 tons of heat cool. So this is 5 systems for the price of 1. We get our ventilation with the ERV at 85% heat recovery. There's no makeup area in it for corridor pressurization. We just have a few extra supply and exhaust ducts. Heating with all outside fresh air with no mixing of air between suites. We get cooling and all exhaust fans are eliminated. We have 200 fewer penetrations in the building envelope. Much easier to make airtight and way less thermal bridging and easier to keep the walls waterproof. No Swiss cheese building envelope. You know, no mechanical equipment to service inside individual units. There's no gas in the building, hence no design costs or gas fitters on site. And as Natalie said, our units are heating for $30 to $50 a year, and they're cooling for $20 to $30 a year. And we've got a central controller that runs everything. It's on Wi-Fi. We can troubleshoot it from anywhere. And then we have an inexpensive HRV that we use to ventilate the underground parking. Here's a shot of the controller in the Orion building in the 2021 heat wave. Picture shows 41.6 C incoming air and delivering 13.7 C air to cool the building. The hottest day was 48 centigrade that week, and AC cost $10 per unit for the heat wave. And we had the only cool building in Pemberton that week. The details I have seen to make a building airtight are usually way too complicated and difficult to make work. So just push the easy button. We've been using EFIS from ZEBx, the secret to making everything else work. It's high quality, durable, low maintenance finish. In one product, you get like 7 functions from one trade. We get a liquid applied air water barrier, which is the easy way to make your building airtight. You get a drainage plane. There's no thermal bridging with the EPS adhesive attached. You get an R24 exterior insulation, and they have fully worked out simple details. They're fast, low cost, and airtight, all done by one trade who are very good at it. Then we use compatible products from ZEBx for the window and door openings for simple detailing that is easy to install and rock solid. And EFIS has been around longer than me, so it's a well-established technology that works great in our climate. Super simple details for window prep with the ZEBx Flex Sealant and mesh. It's almost impossible to damage after insulation. It's tough as nails. And the only window flashing we need is the sloped sill flashing. Then we're using the Vecca Softline 82 windows. They're triple pane, triple weather sealed, low solar heat gain coatings to keep the building cool. And we install them from the inside, which is so much safer and faster and easier to install than the typical flanged windows that you need to be installed from the outside. So no ladders or scaffolding required to install windows. And here's the finished outside window prep. We use the Siga or Rothblast tape on the 2 sides and top, and it adheres to the ZEBx window system. And there's a finished window. Our cantilever decks, super simple. We just cantilever out some deck beams, and we place them where we have rim joists. They just replace the rim joist. Then we use some surface mounted Sherpa connectors for the joists, and then we finish it with Canadian-made aluminum craft-built decking. Water heating is the largest energy use in the building, even using efficient heat pumps. So here's some sand-in heat pumps under the roof overhang to keep them dry and snow-free, and some heat trace lines out to them. We use a little UPS for the heat trace in case of a power failure in freezing weather. We spray foam the hot and cold water lines. It does a better job. It is much faster than the typical wrapped insulation. And the better insulation saves a lot on the hot water recirculating system, which can easily use as much or more energy than the consumed hot water. Then we use a little 36 kilowatt boiler for the swing tank, and it acts as a full backup water heater. Want to use a Canadian product? Arctic heat pumps from Manitoba, built for Canadian weather. We have 1 heat pump for heating, cooling, and hot water. Just add the ERV for the air handling unit and a few hot water storage tanks. It's all fully backed up with an electric boiler. And we can stack the heat pumps in 5-ton increments for our larger buildings. And there are hydronic systems, so no refrigerant inside the building and no refrigerant technician needed on site. Here's the setup we're using for our 4-plexes, and it's the same design that we use multiple ERVs as the air handlers in our buildings. They're off-the-shelf components available across Canada. And any plumber who's installed an in-floor heating system can easily install this. It's all the same components. Okay, we're using the Casa series from Swagon. They have multiple sizes that we're using as the air handlers in many of our buildings. When they do not have enough capacity for the larger buildings, we just switch to the larger Swagon Gold RX series. They are well suited to our cold climate and have a very high efficiency rating. So how can you use an ERV for all the heating and cooling? You simply do not have enough airflow capacity. Well, this is how integrated building design works. Lower the heat loss by 90% by building a better building envelope, which does not have to cost more, just make better choices. Now the design heat loss can be accommodated by the ventilation rate airflow if we double the minimum required ventilation rate. The benefit is a healthier home. And since the cooling load is greater than the heating load, the ERV is sized using its maximum airflow rate for boost cooling, which will only be needed during a heat wave. The ventilation rate can accommodate 80% of the cooling. The ERV is now running at an easy 60% of its rated capacity, 99% of the year. But we're over ventilating and that costs too much. I've heard that way too often. Well, who cares when your heating costs are $30 to $50 a year? The multiple effects of a 90% reduced heating load, the 85% efficient ERV, and the heat pump COP of 3 reduce the penalty for overventilating to a cup of coffee. Here's the A-team in Golden at OSO doing the blower tower test. And on the first test, they got a 0.2 ACH. We just finished a single family home that got a 0.3 and a mid-test on our duplex at 0.39. Simple details make these results much easier to accomplish. And now construction's not an easy job at the best of times. Design your buildings to be easier to build and you'll get better results. We need to design our buildings to optimize the materials and systems we have already perfected in Canada today. This brings us to the IBG Design Library. It takes advantage of our accumulated knowledge on how to build affordable, climate-resilient, energy-efficient homes. This is the community building, which is our most popular design. It's optimized for ease of construction, either on-site or off-site panelization. It can be built in 3 to 5 stories, slab on grade, crawl space, or underground parking. And we can have multiple buildings side by side. It's got some nice wide exterior walkways, which are great for casual socializing with your neighbors. We have 4 different floor plan configurations available with the exact same exterior wall structure and HVAC system. We can incorporate a commercial ground level, have underground parking, or a slab on grade. So here's 7 building configuration that has commercial and community space with surface and underground parking. This is on a sloped site in Vernon. And there's another version that will have 3 buildings, all using the same plan with some specific site adaptation. 3 to 5 stories, 20 to 50 units, or an 8-plex. 75 units or 4 units. So we have lots of options available, and they're all using the same easy, simple construction methods, mechanical systems, and materials that we are already good at building with. Here's our 8-plex that we're going to do a kicking horse, 89 units in seashell. Standardized designs can work anywhere. Keep them simple and versatile, and design them to work in all our climate zones and within the skills of the trades we have today. Now back to you, Natalie.
Thanks, Rod. I think you just dumped so much great information into this presentation in the minds of those listening today that there's almost not nearly as many questions as I expected, probably because they're just digesting all of that great information. So kind of my role at the end of this presentation is just to pull together some of the threads, the overarching takeaways. So number 1, the technical takeaways, I think that reiterating that overlap of high performance, low carbon building and prefab. The 2 focus areas for a lot of high performance work is a high performance envelope, arguably also structure, as well as efficient HVAC and overall just MEP systems, like targeting those systems. And arguably those are also the systems that we want to be focusing on when we're targeting prefab. Can we put in, wall systems that are highly insulated that, Rod spoke about earlier? Can we use some of those heat pump systems and get the resilience benefits as well as a really comfortable, affordable home. On the additional pieces that I don't want to diminish is that appropriate training and coordination between trades. The folks that are building your building, you need to have those designs speak to those who are actually doing the work. And I think Rod just demonstrates this in such a compelling way that if you keep those folks in mind, you get much better products. I think also if we're looking at larger scale prefab, scaling up this type of housing, software tools, and making sure that we can have more precise modeling and more efficient use of energy and materials in those models. So digital twins can be extraordinarily helpful when we're creating those initial standardized designs, I think is incredibly important. So these, you can kind of see the two pieces on the far right as the supporting mechanisms, and then the two on the left as the core tenets of achieving both high performance homes as well as integrating prefab components. Next slide, Rod. I thought I would highlight one of many resources that we have. Monty, the late Monty Paulson, an absolute excellent educator and behemoth in the field of green building, did an excellent video talking through kind of the highlights of high performance buildings. And if you want to dive in more, if you don't actually have a lot of knowledge on the topic, I think that diving into some of these resources would be really, really helpful for just getting a grounding on how to build these buildings in a way that, you get those excellent air changes per hour that Rod was speaking about. And obviously, I'm going to elevate ZEBx because we have a lot of really intelligent humans and great businesses that we're elevating, doing excellent work. Next slide. As our final slide, the key, our overarching takeaways slide. These are components that that I've mentioned throughout this presentation that Rod has talked to, is that prefabrication really can help build in energy and material efficiency. If coupled with highly repeatable and easily installable components, we can get those cost savings. So designing with repeatability and buildability top of mind is really key to reducing cost and increasing the quality of our buildings. And Rod and IBG's experience demonstrates that with pragmatic, knowledgeable, and open-minded local governments and builders working together, high performance and prefab-ready standardized designs can result in more affordable buildings. IBG's experience demonstrates that this is feasible. The good news is also Rod and IBG is not the only ones doing really great work on this. And so selfish plug, I guess, is ZEBx is a network that is full of really, really keen folks trying to figure out how to make this stuff work. And so check out our website, connect with me, reach out, chat with Rod. We want to share this information and move this work forward. So maybe back over to you, Alex, and we can open up for a discussion.
Thank you so much, Rod and Natalie, for sharing your insights. We have lots of questions. I was really concerned that we weren't going to have a multitude of questions coming in, but now they're starting to flood in. And really, kudos to both Natalie and Rod. People so impressed with your insightful analysis and your work, Rod, just in advancing the conversation and building practice for delivering on near zero, being offsite ready, and really effectively managing cost.